So in this particular question, we have to find the coefficient of x raised to the power of 10 in the binomial expansion of 2x squared minus 3x or raised to the power of 11. So we begin by assuming that the term containing x raised to the power of 10 be the r plus 1th term. Now we try to find out the general term corresponding to r plus 1th term, and that will be equals to 11cr times the first term, which is 2x squared raised to the power 11 minus r, times the second term, which is negative 3 over x raised to the power r. This will be equals to 11cr times 2 raised to the power 11 minus r times x raised to the power 2 times 11 minus r times negative 1 raised to the power of r times 3 raised to the power of r divided by x raised to the power of r. For further simplification, we get 11cr 2 raised to the power 11 minus r times 3 raised to the power of r times negative 1 raised to the power of r. So we're writing all the constants together. Then we have 11 raised to the power of 2 times 11 is 22 minus of 2r, and the exponent of x in the denominator will go to the numerator and get subtracted. So it will be minus of r. So this finally gives us 11cr 2 raised to the power 11 minus r times 3 raised to the power of r times negative 1 raised to the power of r times x raised to the power of 22 minus 3r. Now we have to find out this dr plus 1. We have to find out the term containing x to the power of 30, x to the power of 10. So in order to find that, so we will make the assumption that x raised to the power of 22 minus 3r is equivalent to x raised to the power of 10. So this will help us to find out the value of r. So we equate the exponents to get 22 minus r equals to 10. We have negative 3r equals to 22 minus 10, which gives us negative 12. We multiply both sides by negative 1 to get 3r equals to 12, which gives us r equals to 12 over 3, which is 4. So this is the r value. So now we assume that the r plus 1 term is the term that contains x raised to the power of 10. Therefore we can say x, therefore we can say 4 plus 1 that term, that is the fifth term of the binomial expansion of the fifth term of the binomial expansion of 2x squared minus 3 over x, 2x squared minus 3 over x raised to the power 11 contains x raised to the power of 10. So this is the answer. Let's go to the next one. So here we have to find out the coefficient of x raised to the power of 10. So what we do, we replace the value of r by 4 into our general term. So let's take this term and we're going to replace r value by 4. So this gives us 4 plus 1, which is 5, equals to 11c4 2 raised to the power 11 minus 4 is 7 times 3 raised to the power of 4 times negative 1 raised to the power of 4 times x raised to the power of 22 minus 3 times 4, that will give you 10. Now we compute the coefficient. So 11c4, when we compute the value, we get 421, 440, negative 1 raised to the power of 4 is positive 1 times x raised to the power of 10. So we are asked to find out the coefficient of x raised to the power of 10. So this is the value. So in this question, we have to find out the coefficient of x raised to the power of 32 and x raised to the power of negatives 17 in the expansion of x raised to the power of 4 minus 1 over x cubed raised to the power of 15. So let's begin by assuming. So we'll assume that the term be r plus 1th term. This is the one that contains either of it, either x raised to the power of 32 or x raised to the power of negative 17. Then we find out tr plus 1, which is equals to 15cr times the first term, which is x raised to the power of 4 raised to the power of 15 minus r, times negative 1 over x cubed raised to the power of 15. That's raised to the power of r. So this is equals to 15cr, x raised to the power of 4 times 15 is 60, minus 4 of r, times negative 1 raised to the power of r divided by x raised to the power twice of r, which will be equals to 15cr, x raised to the power 60 minus 4r minus 3r. So we'll write it down. So what we have done, we have taken the exponent of x in the denominator to the numerator and subtracted it, times negative 1 raised to the power r. So that gives us the final one as 15cr negative 1 raised to the power of r times x raised to the power of 60 minus 7r. So this is our r plus 1th term. Now in order to find out the coefficient of x raised to the power of 32, to find the coefficient of x raised to the power of 32, what we do, we equate x raised to the power of 60 minus 7r equals to x raised to the power of 32. So that should give us 60 minus 7r equals to 32. So we have 7r equals to 32 minus 60 minus of 7r, that would give us 28, negative 28. We multiply both sides by negative 1, so that gives us 7r equals to 28. So the final value of r is 28 over 7, which is 4. So this is the r value is 4. So we can say that the fifth term, so our r plus 1th term corresponds to the fifth term. So the fifth term contains x raised to the power of 32. But in the question we are being asked to find the coefficients. So to find out the coefficients, we consider the term. Let's copy it. So now we know that the r value is 4. So we replace it. So that gives us d5 equals to 15c4 negative 1 raised to the power of 4. So this is going to be the coefficient part. So let's write it. So the 60 minus 70r is 32. So we have to find out the value of 15c4 times negative 1 raised to the power of 4. So 15c4 gives us 1365. And negative 1 raised to the power of 4 is 1. So we have x raised to the power of 32. Since we are asked to find out the coefficient, so the coefficient will be simply 1365. So that's for the first part. Then we move on to the next part where we have to find out the coefficient of x raised to the power of -17 as well. So we're not going to redo it. So what we're going to do, we're going to reuse the value. We're going to reuse this value. I'm going to reuse this value and replace x raised to the power of 60 minus 7r by, well, not exactly replace, we are going to equate this one equals to x raised to the power of -17, which gives us 60 minus 7r equals to -17. -7r is equals to -17 minus of 60. -7r is equals to -77. 7 of r is equals to 77, and r is equals to 11. So we have the 11th term. So we substitute the value. So this will give us t of 11 plus 1, which is equals to 15c11 -1 raised to the power of 11 times x raised to the power of -17, which is equals to -1365 x raised to the power of -17. So therefore the coefficient will be equals to -1365. So in this question, we have to find out the coefficient of x raised to the power of 6 times y raised to the power of 3 in the expansion of x plus 2y raised to the power of 9. So what we do, we start by supposing that x raised to the power of 6 times y raised to the power of 3 occurs in the r plus 1th term. So this is an assumption. From there, we find out the value of tr plus 1, which is simply going to be equals to 9cr times x raised to the power of 9 minus r times twice of y raised to the power of r, which is equals to 9cr x raised to the power of 9 minus r times 2 raised to the power of r times y raised to the power of r. Then we write the coefficient, the constant coefficients together. So 9cr times 2 raised to the power of r times x raised to the power of 9 minus r times y raised to the power of r. So if this one were to, if x raised to the power of 9 minus r times y raised to the power of r has to be equals to x raised to the power of 6 times y raised to the power of 3, what we can do, we can assume, or we can put r is equals to 3. So that is the value. So straightforward, we can find the value of r. So that would mean t 3 plus 1 is equals to 9c3 2 raised to the power of 3 times x raised to the power of 9 minus 3 is 6, and y raised to the power of 3. So we find out the value of 9c3, which is 84, times 2 raised to the power of 3 is 8, times x raised to the power 6, y raised to the power of 3. So 84 times 8 gives us 672. 672 times x raised to the power of 6 times y raised to the power of 3. So there we go. We have the coefficient of x to the power of 6 times y raised to the power of 3, which is simply 672. Let's go to the next one. So in this particular question, we have to find out the coefficient of x raised to the power of 10 in the given expansion. So what we do, we assume that the r plus 1th term contains x raised to the power of 10. Then we find out the value of t, r plus 1, which is equals to 20cr times the first term, twice x squared raised to the power of 20 minus r times -1 over x raised to the power r. And we simplify to get 20cr times 2 raised to the power of 20 minus r times x raised to the power of 2 times 20 minus r will give us 40 minus 2r times negative 1 raised to the power of r divided by x raised to the power of r, which finally gives 20cr times 2 raised to the power 20 minus r times negative 1 raised to the power of r times x raised to the power of 40 minus 2r minus the r which comes from the denominator, and that gives us 40 minus 3r, and this is going to be our rth term. Now to find out x raised to the power of 10, what we do, we equate 40 minus 3r, which is the exponent of x equals to 10. Then we solve for r, and that gives us negative 3r is equals to 10 minus 40 is negative 30, so which will give you r is equals to 10. Now we substitute the value of r into tr plus 1. Let's copy this value. So we got r equals to 10, so this will be 11, which is equals to 20c10. 2 raised to the power of 20 minus 10 gives us 10. Negative 1 raised to the power of 10 will give us positive 1 times x raised to the power of 10. So the coefficient of x raised to the power of 10 is, so the coefficient of x to the power of 10 is 20c10 times 2 raised to the power of 10. So that's the answer. Let's move on to the next one. So in this particular question, we have to find the coefficient of x raised to the power of 7 in the given expansion of the binomial expression. So we assume that the r plus 1th term contains x raised to the power of 7. Then we find out the value of tr plus 1, which is equals to 40cr times x raised to the power of 40 minus r times negative 1 over x squared whole raised to the power of r. When we simplify it to get 40cr times x raised to the power of 40 minus r times negative 1 raised to the power of r divided by x raised to the power of twice of r, which would give us 40cr times negative 1 raised to the power of r times x raised to the power of 40 minus 3r. So what we have done, we have subtracted 2r, the exponent of x in the denominator, from the exponent of x in the numerator. Now to find out x raised to the power of 7, we let 40 minus 3r equals to 7 and solve for r. So that would give us negative 3r is equals to 7 minus 40, which is 33. And solving for r, we get r is equals to 11. Now then we replace the r value into the rth term, so that should give us, so this is tr plus 1. So we replace r by 11, and that should give us negative 1 raised to the power of 11 times x raised to the power 7. So the coefficient of x to the power 7 will be negative 40c11. The negative is coming because negative 1 raised to the power of 11 is a negative number. So that's defined.